Hey, so we're going to learn two proofs for the Pythagorean theorem. So what is the Pythagorean theorem? So the theorem states that the square of the hypotenuse is equal to the sum of the squares of the two other sides. So what does that technically mean? So say you have two sides of a triangle, A and B, and this is a right angle triangle. So A squared, the length A squared plus the length B squared is equal to the length C squared. So you get the famous formula everyone's heard, A squared plus B squared is equal to C squared. But what's the proof of this? So, we're going to do a simple proof and then a more complicated proof. So first the simple proof. Say you have a square. Best square I can draw. And you have another square on the inside. So, the inside square has side length C. This length right here for one of the triangles is A, the other is B. So A, B, A, B, A, and B. So we want to find the area of this big square. So what is the area of a square? So it's the side length squared. So A plus B squared. It's also equal, we can add up all these little triangles and the inside smaller square. So we have 4 triangles, and the area of a triangle is 1/2 the base times the height. So what's the base? B times the height, A. And plus the inner smaller square. So let's expand this side. So A plus B squared is A squared plus 2AB plus B squared is equal to, and I expand this side, 2AB plus C squared. So this cancels out here, and we get the desired result. A squared plus B squared is equal to C squared. And now for a little bit more complicated proof, we're going to deal with a couple of vectors. Say we have the vector x, and x is down the x-axis. Call it 0, and this is vector x. And now we have vector y, which is only up the y-axis. So this is vector y. And now we have a third vector, x plus y. So we want to know what the norm of x plus y is squared. Well, this is equal to x plus y dot x plus y. This again then is equal to x dot x plus x dot y plus y dot x plus y dot y. Now, y dot x are x and y are orthogonal, are perpendicular, so the dot product between them would be 0. So this cancels out, and this cancels out. X dot x is the norm of x squared. Y dot y is the norm of y squared. And so you get the result that x, the length of x squared plus the length of y squared is equal to the length of x plus y squared. And that is the second more complicated proof.